Welcome back to everyone. Today I'm going to solve a problem using regarding equilibrium condition. And equilibrium condition, I'm going to use both combination of Lami'S theorem and equilibrium conditions like sigma fx equal to 0, sigma fy equal to 0. So look at this problem. We have the two cylinders of A weight of 4000 newtons, so this is 4000 newtons, and B weight of 2000 newtons, so this is 2000 newtons, resting on a smooth inclines as shown in figure. So these two are the smooth inclined planes. We have these two rollers in a position. They are connected by means of a bar of a negligible weight hinged to each cylinder at a geometrical center by smooth pins. So we have bar AB. So this is a bar AB. So this bar is hinged, means hinged at its center. So this bar is connected at this center, and this bar is connected at this center. So definitely this bar is under compression because this roller tried to come inside this inclination, and this bar also is try to come inside the inclination. So definitely we have an action of compression. So we have a reaction. So according to Newton's third law, every action there is an equal and opposite reaction. Definitely this bar will gives compressive reaction that is opposite to the motion. So this is the assumed motion of the cylinder, so reaction comes opposite to the direction, say that is F A B, force induced in cylinder. And similarly this roller is comes inside, want to come inside the cylinder, so definitely we have force F A B. So opposite to the motion we have reactions. See, for example, a compression, let me take a bar. If you compress with a force F and F, definitely this bar have some internal energy. That internal energy, the resistance or rigidity, will gives the reaction opposite to the action of the force. So for F we have opposite reaction R. Similarly for this F we have opposite reaction R. So these FAB is nothing but reactions which develop inside the bar, right? So, and also we know that we have a force P. We need to find the force P, which P is pushes inside the cylinder such that the system should be in equilibrium condition. If P equal to 0, what will happen? Just assume if P equal to 0, what will happen? This roller comes inside, this roller moves upside. Definitely, because it having 4000 Newton weight, it is having just 2000 Newton weight. Definitely this roller climbs up the plane, and this roller comes down from the plane. So because of the force P, it is held in equilibrium condition. So what is the required value of P? We must keep on roller B. So that is what we need to find, right? Let us find. So before going to explain anything, we must draw the free body diagram for the given problem. See, we have two rollers of weight vertically downwards. So this weight is vertically downwards, that is 4000 newtons. Similarly, here also weight acts vertically downwards, that is 2000 newton. We have a contact at here. This is contact number 1, and we have a reaction R1 from this contact. So this is 90 degrees, and this reaction is nothing but R1. So this is 90 degrees with the plane. If you extend the horizontal plane, it is 30 degrees because this is 60, this is 90. Automatically 180 minus 90 minus 60, which is nothing but 30 degrees with the horizontal. So we have reaction R1 with 30 degrees to the horizontal. So let us draw R1 in this 4000 Newton diagram with an angle 30 degrees with the horizontal. So let me draw this 30 degrees force So we have 30 degrees with the horizontal. The force is R1. So I didn't change anything. This is in first quadrant. Here also it is in first quadrant. It makes an angle 30 degrees with the horizontal. It makes an angle 30 degrees to the horizontal. Or it makes the angle 60 degrees to the vertical. You can draw 60 degrees to the vertical. Right? This is a vertical surface, right? So for vertical surface, this is 60 degrees. So you can draw, this is also 60 degrees with the vertical surface. So in this way you can draw. Similarly, we have a bar, right? We have a bar. This bar having a reaction of FAB towards the center. This arrow toward the center. Similarly, just join the two surfaces, two centers like this, right? Right? So this is angle 15 degrees. So here we have angle 50 degrees with the horizontal. Here also this arrow having angle 50 degrees to the horizontal. Similarly, this is also 15 degrees. Right? So now this force is nothing but FAB. This is the free body diagram of body A. I mean center A. Coming to center 2, that is body B. So for body B, the self weight already I wrote 2000 Newton, and we have FAB toward the center. And similarly, P is a force with an angle 60 degrees to the horizontal. So we have a force 60 degrees to the vertical. Sorry, not horizontal, to the vertical. Sorry, let me change the direction. Sorry. So this is acting towards the center. So this is P, which makes an angle 60 degrees to the horizontal, right? Now we have a contact surface. Similarly, R1 we have R2. So R2 having an angle 45 degrees, because this is 90 degrees, this is 45, automatically this is 45. So 45 degrees, R2 makes an angle 45 degrees to the horizontal. So this is in, if you have any doubt, just do one thing. This is the starting point. Just draw x-axis, y-axis. You came to know it is in the second quadrant, so you can write this R2 in second quadrant. So we have R2 second quadrant at an angle 45 degrees to the horizontal. So we have 1, 2, 3 and FAB, four forces in diagram B. Here we have 1, 2, 3. 3 forces in body A. Right? In body A we have two unknowns, F1 and RAB. We have two unknowns. In this diagram, in B, we have three unknowns. 1, 2, 3. 3 unknowns. So my suggestion is to go for A. Solve first diagram A, because we have only two unknowns. If you go for B, because of the three unknowns, we must calculate with three unknowns, which is very difficult, and problem will become very complicated. If you go for two unknowns a center, definitely two unknowns will give two equations you can solve easily. If in this equation you can find, sorry, in this FBD you can find FAB. If you substitute FAB, automatically the unknowns will reduce it to 2, then it is easily calculated. So my suggestion is to go with A. So very simple suggestion, go with lesser unknowns, then answer will be very easy. So let us redraw the free body diagram FBD again. Let me draw FBD for body A, only body A. According to our requirement, I am going to use law of transmissibility to solve unknown forces, right? So let us draw x-axis, Similarly, y-axis, this is x-axis and that is y-axis. So this is x, this is y. So weight is always acts vertically downwards. So let us draw weight axis vertically downwards, 4000 newtons. Similarly, R1 is in first quadrant, so use R1 in first quadrant. What is the angle between these two forces? Very simple. The angle between these two forces is 30 plus 90. 30 plus 30 degrees plus 90 degrees. Now FAB going towards second quadrant. If you use the law of transmissibility, you can transfer this force to here, FAB. So if you draw x and y axis, you can see this is in first quadrant. So I am going to draw FAB in first quadrant, which makes an angle 15 degrees to the horizontal. Now I am going to use 15 degrees with x component, sorry, x axis. So now draw FAB 15 degrees with x axis. So what is the angle between these two forces? 90 plus 15. So what is the angle between these two forces? So to use the law of Lami'S theorem, you must know the angle between the forces. That's why I'm finding out the angle between the forces. So 180 minus subtract 15 minus subtract, this angle is 30, right? 30. So that is the angle between the forces, right? Now applying Lami'S theorem. According to the Lami'S theorem, first of all, only we have 4000 Newton known force. Just write 4000 divided by sine. So other than 4000, we have two forces, that is R1 and FAB. What is the angle between them? Just take the angle between them. Sine angle of opposite two sides. The correspondent opposite two sides. Other than 4000 Newton, we have FAB and R1. So FAB, R1. So the angle between FAB and R1 is 180 minus 15 minus 30. So sine 180 degrees minus 15 degrees minus 30 degrees is equal to, so I don't know what is R1, so let us write R1 divided by sine. So other than R1, we have 4000 Newton. FAB, angle between these two forces is 90 plus 15. Similarly FAB, so FAB divided by sine. So other than FAB, we have two forces, that is R1 and 4000. Between R1 and 4000, we have 90 plus 30. So 90 plus 30. So in this equation, I want only FAB, because if you know the FAB, so body B will be reduced to two unknowns. So I want FAB. So FAB is equal to, so we have this value 4000 divided by sine 180 minus 15 minus 30 is equal, so into this will come this side, so here is divided, so here it is multiplied, 90 plus 30. So if you calculate FAB, you will get FAB is equal to 4898.98 Newton. So we got positive value, so our assumption is right, this is under compression, right? You are assumed that body is compression, so you got the positive value, that means it is under compression. If you get the negative value, that means your assumption is wrong, so it is supposed to be execute tensile force, but here we got positive value, so our assumption is correct. So you can find R1 also, no need to find, but if you have interest, you can find, you will get R1 5464.1 Newton. So this is the unknowns you must find. Similarly, draw the x-axis, y-axis to solve free body diagram FBD at B. So again we need to draw the free body diagram to use equilibrium condition. Why we use the equilibrium condition? Because here we have four forces. For four forces we cannot use Lami's theorem. For only three forces you can use only Lami's theorem, but for four forces you can go for equilibrium condition. What are the equilibrium conditions? Equilibrium conditions, that is, in x direction, sigma fx algebraic sum of x components is equal to 0, sigma fy algebraic sum of y components is equal to 0. So to use these equations you must know the forces in all coordinates, that is, the forces must act some angle with x-axis or y-axis. So here we have 2000 newtons downwards. P you can pass P, I mean you can use the law of transmissibility, you can transfer P to this direction. So with y-axis this is 60, here also with y-axis this is 60. So you can transfer P using law of transmissibility. Similarly, FAB is moving towards fourth quadrant. So just transfer FAB at an angle 45 degrees to the horizontal, 45 degrees to the horizontal. So in this way we can use the law of transmissibility, right? So we have totally four forces. Just draw the four forces. So as I said earlier, force is acted always vertically downwards, that is 2000 Newton. The center is B. So similarly, P is acted in this quadrant at an angle 60 degrees to the vertical, 60 degrees to the vertical. Similarly, R2 is acted 45 degrees to the R2 is acted 45 degrees to the horizontal, 45 degrees to the horizontal. FAB is in fourth quadrant, so let's draw FAB in fourth quadrant at an angle 15 degrees. And the last but not least, so all the forces are known. We know FAB is equal to 4898.98. So these forces are in between x and y axes. So you can resolve these forces into components. First of all, P. So first of all we have P can be resolved into two components. One is P cos 60. Another one is P sin 60. Similarly, R2 can be resolved into R2 cos 45 and R2 sin 45. Similarly, FAB sin 15, here FAB cos 15. So you can resolve the forces according to the requirement, right? Now apply equilibrium condition in x direction. Sigma fx equal to 0. Sigma fx is equal to 0. For the x directional forces, we have x direction. This is positive direction. This is negative direction. For positive direction, only one force, that is plus FAB cos 15 degrees. Negative direction, we have two forces, that is minus P sin 60 minus R2 cos 45, isn't it, is equal to 0. So now this equation can be rewrite as R2 cos 45 plus P sin 60 is equal to 4898.98 cos 15. So R2 cos 45 plus P sin 60 is equal to If you calculate, you will get 4732.05 Newton. Take it as equation number 1. Similarly, algebraic sum of y components must be equal to 0. So what we have to do? So just write the y component forces. So upward we have only one force, that is R2 sine 45, and downward we have three forces, that is minus P cos 60 minus FAB sine 15 minus 2000 is equal to 0. You can write this equation like this: R2 sine 45 minus P cos 60 is equal to, if you calculate, FAB is equal to 4898.98. If you substitute, if you calculate, you will get 3262.94. So it will come sine 45 1262.94. So I'm going to do directly. So this is equation number 2. Now solve equation 1 and 2. So equation number 1, just write equation number: R2 cos 45 plus P sin 60 is equal to 4732.05 minus plus R2 sin 45 minus P cos 60 is equal to 3262.94. If you solve this, if you subtract equation 1 and 2, so if you subtract, this will be minus, this will be plus, this will be minus. Automatically these two will cancel. So you will get P sin 60 minus, it will become plus, minus of minus become plus, P cos 60 is equal to 4732.05 minus 3262.94. So in this equation you will get P value is equal to 1071.79 Newton. This is actual answer. This is the force must be required to keep the system is in equilibrium.